that circuits is like any enclosed loop in which we have to put a source, any conducting wire in which electrons will travel, and current will travel in the back and forth direction. Okay, conventional direction, conventional current will be travel in that closed loop, and we call that closed loop a circuit. Okay, so we will start from the circuit. So basically circuit is a closed loop in which current is travel. So we are going to take a look at the circuit and how we can draw them with a couple of simple components. So as I told you that circuit is a closed circuit, a closed loop. For example, this is a closed loop without any attachment of any kind of components. Okay, this is just a closed loop in which current is traveling. This is just a little bit graphical representation of a circuit. So when we put different kind of components with it, it becomes a complete circuit. Okay, so we also explore the terms potential difference, current, and resistance before finally seeing which way around circuit current flows. Okay, when we are going to study the circuit, and if the current is traveling, if we have to put different components in the circuit, it's mean that we are going to take a look of a potential difference. Potential difference is basically a voltage provided by a source and the current which is traveling around the circuit and the resistance which opposes the effect of current. Okay, so we will start. An electrical circuit is just a closed loop that contains a power source. Okay, and electrical we call it electrical circuit because it is attached with the source and electrons is traveling in this closed circuit, so we call that electrical circuit is a closed loop that contains a power source such as a cell or something for electrons. Okay, we call that a power source or a kind of cell or any kind of the source in which electron will travel. Okay, a power source such as a cell and something for the electrons. Got it? This is the definition of a and circuit. Okay, and the next thing is to flow through like this wire. So electrons will flow, electron to flow through like this, like the wire. Okay, now I will put some components in this closed loop that is known as a complete circuit. For example, we have a closed loop. This is the and this is the cell source, a battery in which electrons will move in the circuit and they produce current. This is a cell. The three names of this cell, battery, and source. Okay. Whenever you whenever a question came about this thing, you don't get confused that what is cell, what is source, and what is battery. These are the same similar things. Okay. And after that we have this wire like this wire and we generally represent them with the current, and this is here is probably the simplest type of current you'll see. Okay, so in the circuit diagram after this we have this is the circuit diagram. We can show the direction of current. For example, this is the always the bigger side shows the positive and the smaller side shows the negative. So current from moving this to this to this, or sometime to this to this to this and to this different direction of current. Okay, so in order to draw more complex circuits we need to know these symbols. So this is a basic circuit. We have so many components of circuit, so we can draw a simple circuit to the complex one just putting a different component. Okay, So we need to know these symbols for the different components and where to place them. There's a whole bunch of symbols that you need to know, and I'll cover them all in the more detail for you. For now, we'll just consider the main ones, which we already seen for ourselves, which is basically just a simple version of a battery. So we have take a look on the first components. I will write the heading of components of a circuit. And the first component I wrote here, which is a cell. It's mean that this is a component of battery. Okay, battery. Batteries are made up of two or more cells. Their symbol, okay, batteries are made up of two, like these two, or more than two cells. Their symbols is just their symbol is just two cell symbols put together. Although as far as exams are concerned, cells and batteries both act in the same way. Another common symbol is for the filament lamp we use. For example, if you are doing a practical on how electricity is conducted in a circuit, you just use a source and you put a filament lamp, you attach that filament lamp in that closed circuit. So when you provide the electrons, when the current starts to begin flow in that circuit, the filament lamp will blows up, which shows current is passing in that circuit. When you close that switch, when you turn off the current, the filament bulb will go down, will off. Okay, this shows some kind of deflection in the circuit, which shows current. Okay, how many components will take a look right now? I told you three different components in a simple circuit. If we are doing a simple practical on a simple circuit, we just want to see that a light current is traveling in the circuit and a light will blows up and a bulb, an electric bulb, filament bulb will blows up, will get light. We're just doing that practical. Just imagine that, okay? For example, we are doing a practical number one in which we have only three components of a circuit. Okay, how many components we have for this practical? Only three. So if we have to draw, firstly you have to mention that components before drawing. We will use, this is known as battery, cell or source from which current will flow. Okay, and the larger side shows which sign? Positive, smaller shows negative. And next we have this. What we call this? Filament. Yes, filament lamp. Filament bulb. Yes, filament lamp or bulb. You can give both names. Okay. And after that we have this thing. What is this? Switch. Yes, this is a switch. So now I have to put these three components in my practical number one, in which I just want to glow up, want to turn on this filament bulb or lamp in the circuit. So I will draw. There is not a necessary thing where you have to put these things. There's not a such location for these things. We just put that thing in every wire, but each and every component should be in a single line. Okay. It's mean that if we have to place filament left, then we cannot place switch here. Switch will be in another wire, and the film and the source will be in another wire. Okay, we cannot put two components in a single wire. And after this, I will draw this circuit. So here I put the switch. Okay, so this is the switch. This is the switch. Is right now it is turned on. Okay, while doing any kind of practical in your physics laboratory, make sure that if you're connecting any kind of switch in the circuit, firstly you have to turn off that switch, okay, before doing any kind of practical with these wires and with this circuit. So here this one will go simple. Here I put the filament lamp or a bulb. And in this I put the battery, the source. Okay. Now for example, assume that this switch is off because I turned that off. Okay. So when I turn that off, there is no current flowing in the circuit. That means the bulb will be off. Okay. When I put that switch on, the current will start flowing in the circuit. When the current starts flowing in this circuit, the filament lamp will lights up, which shows that this circuit is working and this light is carrying a current. And current means that passing the movement of electrons in a circuit. So this is the first three components in which we can perform a simple practical by just turning off and turning on that light bulb. Understood about these three components and their functions? Okay, next thing which will disrupt other circuits and so turn off the light. In order to explain what's going on, need to look at some key terms. Specifically, pretend now this is the basic thing I told you about this. Okay? There is a different kind of things are going on in this circuit. The potential difference, the current is flowing, and there is some kind of resistance is also flowing in the circuit. So first thing we have to understand the concept of potential difference. Okay, so the potential difference. Potential difference, current and resistance. Current denoted by the letter I. Okay, so current, the potential difference, the current, and at last we have the resistance. And there is a kind of special alphabet which represents these quantities. Okay, we cannot use the whole written form of current in any circuit. We have to represent that current, and current is represented as small I, capital I. Current is represented as capital I. For example, if you are going to tell me the current is traveling, you have to put an capital I with the direction of arrow, which means that current is traveling. Okay? Okay. So basically, current is the measure of flow of electrons around the circuit. What is the current? Current tells us that how much electrons will be travel in 1 second or any time of interval you can take. Basically, what is current? A measure of. Have you ever noticed that we have a main switch at our homes and that gives us some kind of voltage, how much energy is, how much light we are taking from the main transformer. And there is also a kind of digital representation which gives us, which told us how much current we have to use and how much current is used. Have you ever noticed these things in your home? Main switch, the digital reading. So this is basically how much ampere of current we are using and how much ampere of that we are getting from the main transformer. So a measure of the flow of electrons. Basically, current is the flow of electrons in the circuit. Flow of electrons around the circuit. If I have to draw the electron, that's mean I can draw it. For example, these are the electrons that are traveling in this closed loop of circuit. So and after similar to the flow of water through a pipe, it is measured in amperes, which are often just called amps and are denoted with the letter A. So now we have to understand the SI unit, the system international unit of current. As I told you about that in physics, if every quantity we have to learn, we have to understand, and every quantity in the physics, that quantity has the basic unit, which more identify, which gives more information about them. And then it is represented as capital I, and its SI unit is amperes. If you have done any kind of practical in a circuit, then you must use some kind of meters, ampere meters. Have you used that device which measures the current, which is known as ammeter? Yes, that is known as amp. Why we does not call that a current meter? Because it has a unit. We call it as a ampere meter, which measures the current, ampere, and it is denoted as small a, or sometimes capital A. Okay. For the idea about the current which is traveling in the circuit. Okay, so a potential difference denoted by a V, which is denoted by a capital V. Capital V, okay? Basically, potential difference, force driving the flow of electrons. You know, from the source, electrons are generating and they are moving in the circuit. So if we want a more force, we want a more speed. So we provide a potential difference to that ends of the source. When a high voltage is provided to that source, a potential difference is provided to that source, electrons start moving fastly. So by potential difference is the force driving the flow of electron current. The electrons which are traveling in the closed circuit, this is because of the potential difference. So I'm going to write the definition. Force driving the flow of electrons. Okay. Whenever you put your phone in a charger, you have ever this thing is basically this feature is basically in most of Android phones. I think now maybe it's came on the Apples as well. Whenever you put your phone in a charger, they show some kind of energy. Whenever you put a charger, it shows increase your numbers of charging. Okay, when they increases, they show some kind of movement that is coming from the charger. Have you ever saw this feature? See this feature in the Android or Apple phone. Whenever you put a phone in a charging, saw some kind of changing in our battery's percentage, because this is because we providing our phone some of kind of electrons. When that electrons come to in the mobile phone, they give energy, they are producing energy, they are producing current in our phone, and that current increasing gradually. So it gives a higher percentage to our battery. It completes, when it completed, it gives a 100 percentage, so we unplug the charger. This is also a example of this circuit when we put our phone with a charger. This is also a closed circuit in which our phone is getting an electron, getting a current from the charger. Okay. So by V is the force driving this flow of electrons. This is provided by the cell law battery. You can think of this as a pump that forces the water along the pipe. So we have a pump, we have a tap which is attached from the string. When you turn on that tap will shower the water, okay, in very high speed. If you open the whole one, if you open the lowest one. So basically potential difference is just like a tab in the circuit. When you turn on the electron, it just provides power, it just provides force to the moving electrons. Okay. Then this is provided by the potential difference is provided by the cell, means the battery source. Okay. And another name for the potential difference is voltage. As you have anytime you look on the main switch of the house, there is a voltage which told us that how much voltage, how much ampere of current we are getting from the transformer. If they are show some deflection, it means they are increasing or they are decreasing. That is the voltage which is coming from the source. The source is a transformer, and we have a circuit in our house in which current is traveling in our each room in circuit. And every when we turn on the light, we can turn on the fan, we can use any electrical appliances. Okay. So another thing you have to write is second name, that is voltage. Got it?